So today we're going to start with our warm-up before we move on to something new. So I just want to make sure that you guys have completely got in multiplication and working with decimals before we move on to division, because that's what we're going to do today. So I want you guys to do this on your own, and then I'm gonna call somebody to come up and do it and show the work to the rest of the class. So Jeremiah always rides his bike to and from work. The total length of the trip to and from work is 14.6 kilometers. Last month, Jeremiah worked 18 days. How many kilometers did he ride his bike to work, to and from work? So we have 14.6 kilometers for 18 days, and we want to know how many kilometers did he ride his bike to and from work last month. So do that on your own, and then I'll call somebody up. Jess, did you do it? Or you want to come up and do it for me?
I did.
Okay. All right. You can come up. And then we'll all check and see if we agree with Jess. Jessica. Everyone has a nickname.
Everybody knows 8 times 6, so
You want to write it
what
out?
do you think 8
Show
times
them?
6 is? 48.
He just said everybody knows.
48.
Make sure you write it out so they know exactly how you're working.
So 48.
Put the 8. Carry the 4.
So 8 times 4, which means
32.
32.
I hear some 36s and 32s.
So what do you think?
32.
And then we're going to add that 4, right?
Which equals 36.
Good. So
And that's
technically,
why.
that could be why we heard that. So we're going to put the 6.
And then carry the 3.
Good.
And then 8 times 1 is 8.
Plus
9, 10, 11.
Good. And we're going to put the 0.
We're going to ignore the decimal. And after we 1 times 4.
Make sure you put your 0. Good.
1 times 4 is 4. And 1 times 4 is 2.
Good. Now we're going to add it all up. So everybody got what Jessica has so far?
Yes. Yeah.
Okay. Let's wait and see what the final answer is. How many decimals did we have? 1. So we're going to move 1 in. Good. Okay, did everybody else get 262 with 8/10 kilometers? Good. Okay, thank you, Jess. What? Okay. Thank you, Jessica. All right, so our objective was that we can find patterns in quotients when dividing by powers of 10s. So who can tell me what they remember when we have 10 to the 0 power? Maria?
When you add 10 to the 0 power, you still
Well, we still have the 3, but why do we still have the 3? Because what is this? What is 10 to the 0 power equal? Zamaya, you want to help her?
10.
0? It equals 10, but why? Because this is a 1. When we have something to the 0 power, that just means 1. So we're going to multiply this by 1, which would give us 33. That doesn't look good, so we're going to go darker.
It's 10 to the 0 power, so it's over 3. We say 30.
Okay. Now what about if we have 10 to the first power?
Oh, I know 30. Because it says 0 at the top of the table. But if you had the next one, if you go 0, because it's got 1 on it.
Because 10 to the first power is still 10, right?
Yep.
So that would be 30. Okay. And 10 to the second power is 300, yeah.
Your adding the 0.92.
And then this one would be 3,000. Good. Okay. So what do you guys notice about every time that our power is increasing? What do you notice about our responses? Adrian? Yeah, we're adding one more zero to the end, right? So how does that change our actual product, the answer? Yeah, it gets.
And I also know that the first one, because I thought it was 30, we said 30, you leave out the zero because it was a
Because
zero on
right?
top, and when you get to the
Zero
next one,
there, so there
you
should be
add
no
the
zero.
So
Yeah.
it'll be the 3, it'll be the same for the first one, but then we get to the rest. Add the zero.
Yeah. So our products are getting 10 times bigger every time that we raise our power up one more. So we are going to start working on division now. I just want you guys to help me unlock this problem. The Healthy Wheat Bakery uses page 201 in your fat book. Everyone wants to turn there, please, 201. So you can follow along in your book with the responses.
What page is it?
201. It's right here. If you have any questions. Okay, so I'm going to read it. The Healthy Wheat Bakery uses 560 pounds of flour to make 1,000 loaves of bread. Each loaf contains the same amount of flour. How many pounds of flour are used in each loaf of bread? So we know that we have 560 pounds of flour. We need to make 1,000 loaves. And we want to figure out how many pounds of flour are in each loaf of bread. So how do you think that we would figure out if we needed the same amount in each of the loaves? How do you think we would mathematically figure out how much flour we need? So we're going to take 560 and we're going to divide it by 1,000. I know it's really confusing because it's all new. So we're going to divide it by 1,000 because we want to make 1,000 different loaves using just that 560 pounds. So we need to divide that 1,000 times, and that's how much is going to be in each individual loaf of bread. So down here, hopefully this will work. Not really.
Have to use the computer.
It's all right. You can see all the problems you need to see. Okay, so we're dividing 560 by the 1,000. So over here, they showed us that when we divide it by 1, because remember we're doing powers of 10s, it's still 560. Now when we divided it by 10 right here, what happened to the decimal? It got moved to a different spot. Which way did it move? To the left, right? So what happened to the number? Is this number bigger or smaller than that number? This one? Smaller than that one, right. Now look over here. This is interesting because I see division over here, but multiplication over here, and it's giving me the same answers. So we know how to do this over here, right?
Multiplication and division is the same.
Yeah, they work hand in hand. So here, we're multiplying by a smaller number to get a smaller answer, but division automatically makes the number smaller on its own.
Yeah. When you have two people of the number and you can't figure out what it goes in, you times that times something.
Yep, that's why it works hand in hand with division. So, and then when we divide it by 100, so here we divided it by 1 and it stayed the same. Here we divided it by 10 and it moved 1 over. Here we're going to divide it by 100, and what did we notice here? Pyra?
It doesn't move twice.
Twice, right, because there's 2 zeros in that 100, so we know that we need to move it over twice. And but so the problem is asking us divided by 1,000. So down here, what happened to our final answer when we divided it by 1,000? How many places did it move over? Anaya? This one right here. Alejandro, you wanna help her? 3 places, right. And why do you think it moved 3 places? Hiram? Right. Okay, so what are we gonna put in here? How many pounds, or what decimal percentage of the pounds are we using of flour for each loaf? Alicia?
0 and 5.
Yeah. So we're gonna, in our book, we're gonna write here, we're gonna write the same answer. 0.560, 560 thousandths in that line. Everyone's writing? I don't see pens moving, pencils. Okay, so I want you guys to think about this. As you divide by increasing powers of 10, so as that number gets bigger, how does the position of the decimal place change in our quotients? So look, just kind of observe here. We see it as this is getting bigger. Our decimal place is moving where?
Wait, what do we write?
To the left.
You write
To the left,
You
good.
write it in that soapbox.
You want me to write it? Okay. Alright. So we're using 560,000 pounds of flour in each loaf. And when we raise our power, we're moving our decimal place to the left. It's getting smaller each time. Does everybody have that written down?
Yeah.